Okay, welcome back to Math 103 College Algebra at Central Connecticut State University. This is section 2.2, linear equations. In this video, predominantly, we're going to look at solving equations. So you'll notice an equation is a statement that two mathematical expressions are equal. Okay, this equals that. Normally, we're used to looking at graphing linear equations where we would say y equals 3x plus 5 or y equals ax plus b. In that scenario, we're really looking at an equation in two variables. Notice there's both the x and the y. In this video, we're going to restrict our conversation at this point to just linear equations in one variable. So you'll notice the equation ax plus b equals 0. So you've got the variable term with the ax, and b is simply a constant. Okay, and this equation gets pretty boring if a and b are not. Take that back. If a is 0, you don't really have linear equations. So a and b are both constants. A is not equal to 0. To solve the equation symbolically or algebraically, we're going to use the properties of equality. Okay, if I have a equals b, I can add c to both sides. Or if a plus c equals b plus c, I could subtract c from both sides and go back to a equals b. In other words, I can undo addition or subtraction by using the opposite operation. The same that's true for addition is also true for multiplication. So very quickly, briefly. Example 1. Okay, if we're going to solve this equation, 3x plus 2 equals 17. Remember, the goal of solving an equation in one variable is always to get down to x equals a value, x equals 2, x equals 3, to solve for x. So I have the 3x plus 2. I'm going to eliminate that 2 from the left-hand side. My goal, again, is to get the x all by itself. So when I subtract 2 from both sides, 3x plus 2 minus 2 leaves me with just a 3x on the left-hand side. 17 minus 2 is 15. I've eliminated that plus 2 from the left-hand side. Now I have 3 times x. To undo that multiplication by 3, I simply divide both sides by the 3. 3 divided by 3 is 1. We often say they cancel out. I don't like that. 3 divided by 3 is 1. So we're left with 1x. And 15 divided by 3 equals 5. I am very fussy. If I want to know, if I need to solve for x, I'm looking for the solution to say x equals 5. Okay. What's your favorite color? My favorite color is blue or green. Okay. In a case like number 2, where we have the variable term on both sides, we have a 5x on the left and a 2x on the right. It's really the same type of scenario here. The situation is I want to accumulate all of the terms with the x in them to the left-hand side. So I'm going to subtract 2x from both sides. Notice when I do that, when I subtract the 2x from both sides, I'm now down to an equation, 3x minus 4 equals 12, which looks very much like the number 1. Okay, so to undo the minus 4, I'm going to add 4 to both sides. So 3x equals 16. Okay, we had 3x equals 15, divide both sides by 3. We have 3x equals 16. We're going to divide both sides by 3. X equals 16 thirds. Depending on which situation you're in, if you're a student in my course, I'm very happy with 16 thirds. I prefer 16 thirds. The improper fraction or top-heavy fraction, I know that some people will want you to make that 5 1/3. I personally believe the 16 thirds is just fine. So let's carry on. At this point, it becomes an order of operations scenario. 3 times x minus 4, that 3 is going to be distributed to both the x and the minus 4. So the 3 times x is 3x, and 3 times negative 4 is a negative 12. There's nothing to do yet on the right-hand side. Now I'm going to subtract 2x from both sides. x minus 12 equals negative 1. When I add the 12 to both sides, what's nice here is that subtracting 2x, I had 3x minus 2x, which leaves me with just 1x. I'm not going to have to do a division. Adding the 12 to both sides just gives me straight to the answer, and the answer is the full statement, x equals 11. Number 4, not only am I going to distribute the 2 on the left-hand side to both the 3x, giving me 6x, and the negative 1 giving me negative 2, but on the right-hand side here, this is just like a negative 1. I'm going to distribute that negative 1 to both the x and the negative 1 inside the parentheses. So the negative 1 times x is a negative x. Negative 1 times negative 1 is a positive 1. Depending on your comfort level with your algebra, you may choose to just combine the 3 and the 1. 3 plus 1 is 4. Be careful that you don't attribute this minus to the 1. This minus is only for the x. Okay. Now I'm going to add x to both sides. So I have 7x minus 2 on the left and 4 on the right. I'm going to add 2 to both sides. So 7x equals 6. I'm going to start again over here just so I don't run into my next problem. Now I'm going to divide both sides by the 7 so that the 7x divided by 7 leaves me with 1x, and that equals 6/7. And just like I said earlier, I'm very happy with the fraction. If I want to change that to a decimal, it's likely going to be a decimal approximation, and I can always get that later if I need it. You'll notice now that numbers 5 and 6 each have fractions. So I'm going to want to clear the fractions first. The first thing I want to do, like I said, is to clear the fractions. You'll notice that in number 5, we have a denominator of 4 in both of these fractions. So what I choose to do is to multiply. I'm going to rewrite this to give myself more room. I choose to multiply both sides of that equation by 4. And what that's going to do for me is it should eliminate my fractions, because now 4 times x over 4 is 4x divided by 4, and those 4's will cancel. And that will leave me with just x. 4 times the negative 2 is negative 8. 4 times 1/4 is 4 times 1 over 4. So I'm going to have x minus 8 equals 1. I add the 8 to both sides. X equals 9. So one of the things that gets people in trouble with the algebra when they're not comfortable with it is trying to do too much all at one time. Okay, so you want to be careful with that. Number 6, there's some multiple ways that you can attack this one, but notice I have a denominator of 3 and 2 and 6. The smallest number that all three of those divide into is 6. So what I'm going to choose to do is to multiply everything by 6. The whole thing is going to get multiplied by 6. So I'm going to have 6 times x plus 1 over 3 minus 1/2 x times 6. Maybe I'm writing that. Let me not write that way. So I'm going to have minus 6 times 1/2 x. 6 times 2 is 12. Now I've got minus 6 times 1/6 times 2 minus x. And forgive me here, every once in a while, things will go wonky. So 2 minus x there. So 3 goes into 3 once and into 6 twice, where 6 divided by 3 is 2. 6 divided by 2 is 3. 6 divided by 6 is 1. And notice that that will clear all of my fractions. Cleaning this up, I have 2 times x plus 1 minus 3x, right? Here's the 3, here's the x. 3 times 1 times x is 3x. Copying down the 12. Now we've got minus 1 times 2 minus x. Okay. If I get more comfortable with the algebra, I can zip through this a little bit more quickly. Okay, but if I'm not as comfortable, I want to make sure that I take more time with my steps. So now what I'm going to do is I'm going to distribute this 2 to both the x and the 1 like we've done previously. I'm going to distribute the negative 1 to the 2 and the negative x like we have done previously. So I'm going to have 2x plus 2 minus 3x. And on the right-hand side, we have 12 minus 2 plus x. I'm going to combine like terms. On the left, I have 2x and a negative 3x. That's a negative x plus 2. On the right-hand side, the 12 and the negative 2 will combine to give me 10. And my sizing went off. Bear with me while I fix that. Okay. So now I can handle things either way. I can subtract x from both sides. Personally, I don't like to do that because that's going to leave me with a negative 2x on the left-hand side. I instead choose to add x to both sides. So I have 2 equals 10 plus 2x. And again, let me restart. 2 equals 10 plus 2x. Now I'm going to subtract the 10 from both sides. So 10 minus 10 will give me 0. So the right-hand side is 2x. 2 minus 10 is negative 8. And I did it again. Divide both sides by the 2. Negative 4 equals x. Now I can just simply switch that around and say if negative 4 equals x, x equals negative 4. Okay, hope that makes some sense there. In a little bit, I might need to erase that to make some room for number 8. Before we get there, let's look at number 7. Notice that in both 7 and 8, we have decimals instead of fractions. It works the same way. 3.4 is 3 4/10. I'm going to multiply the left side of the equation by 10 and the right side of the equation by 10. And I'm going to rewrite that to give myself some room. Now when I distribute the 10 to the 3.4x, I get 34x. 10 times 4 is 40. 10 times 6.1 is 61. I know a lot of people say, I have a calculator. I can just do this with the decimals. I don't mind using decimals. You can go ahead and do that. Personally, I don't use a calculator very much, and this helps me in that situation. So I'm going to subtract the 40. I didn't write minus 40 on both sides. You want to practice not having to write that every time. But I did subtract the 40 from both sides. And I'm going to divide by the 34. So x is 21 over 34. Okay. A quick inspection tells me that the only numbers that divide evenly into 21 are 3 and 7. Neither one of those divide into 34. So I know that that fraction is in lowest term, so I'm going to leave it. Number 8, I'm going to copy this to give myself more space, not only because I ran over with the previous problem, but that 8's pretty close. So I'm just going to space this out. As I'm doing this, notice that each one of these decimals has 2 places, 0.02, 0.03, 0.12. So 0.12 is 12 hundredths. I'm simply going to multiply everything by 100. Multiplying by 100 will move the decimal 2 places. Again, if you have a calculator, you don't mind using the decimals, nothing wrong with that. But I'm going to multiply to get rid of the decimals first. 100 times 0.02 is 2. We've got minus 100 times 0.03 is 3. and then 0.12 times 12. You may be asking why I'm not multiplying the 100 also times the x plus 3. That's because there's no addition going on in there. Okay, so let me just do a little work down here. If I have 2 times 4 times 3, that's going to be 24. 2 times 4 is 8, times 3 is 24. I don't, even if I have parentheses here, I don't do the 2 times the 4 and the 3. You only multiply once. So that's why I don't need to multiply the 100 times the x plus 3 if I did it times the 0.02. At this point now, we have an equation just like we've done so far. So 2 times x, 2x, 2 times 3 is 6, minus 3 times 2x is a negative 6x, negative 3 times negative 1 is a positive 3, and that equals 12. My 2x and negative 6x combine to negative 4x. 6 and 3 will combine to 9. When I subtract 9 from both sides, negative 4x will equal 3. When I divide by the negative 4, the negative 4's divide out, and so I have x equals negative 3 over 4. My pen is giving problems here. So x equals negative 3/4. And there we go. Okay. I can solve equations graphically. To solve them graphically is really not a great way to do it to get a precise answer, but I'm going to show you number 9 just to give you an idea of the sense of what's going on. What I would do for this is I would make two equations, y equals 2x plus 1 and y equals x plus 2. Draw a graph. My graph is not going to be perfect. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I can do this on all of the axes. Remember that when I'm going to the left or down, those are negative. Y equals 2x plus 1 has a y-intercept of 1. From there, we go up 2 and over 1, and up 2 and over 1. And we have this line. Y equals x plus 2 has a y-intercept of 2. We go up 1 and over 1, and we have this line. And we can see that right here, what appears to be the point 1, 3 is where those two lines intersect. I really don't think that's a great way to solve equations, but it can be used. We can look at it that way, okay? So, and then if you notice, if you substitute 1 in for x in both of these sides, 2 times 1 is 2 plus 1 is 3. 1 plus 2 is 3. So if x is 1, both sides equals 3. And that's the meaning of that point. One last piece here. If I'm solving for a variable, it's really the same thing that we're doing, okay? Look at c equals 2 pi r. Suppose we had the equation 12 equals 4r. If r is what I'm solving for, I would divide both sides by 4 to get the r all by itself. If I have c equals 2 pi r, or 2 pi r equals c, to solve for c, what I'm going to do is simply divide by the 2 pi so that I can get the r by itself. And r will equal c divided by 2 pi. I don't have a numerical solution, but that's okay. I solved the equation for r. One more here. If I want to solve number 12 for b, because of, give myself some space here, because of this 1/2, the first thing I want to do is get rid of the fraction. So I'm going to multiply both sides of the equation by 2. So I have 2 times big A, and I'm going to call them big A and little a, since notice the equation has two A's in there. 2 times 1/2 is 1, so we have h times little a plus b. I'm doing the same algebraic steps, but I'm solving for b. Since I'm solving for b, I'm just pretending that the big A, the little a, and the h are just all numbers and handling them the same way I would otherwise. Next thing I would do is distribute the h. So I have AH My pen's running low, that's why I'm having problems. BH, subtract the AH from both sides. 2 times big A minus A times little h equals B times H. Now to get the B by itself, I simply divide both sides by the H. So little b is 2 times big A times little a times h, all divided by h, and we have solved the equation for B. If you try this and it doesn't make sense, I'd suggest putting in numbers for big A, little a, and h, solve that for B, and you'll find yourself doing the exact same steps. So I hope that this was helpful, solving equations, just a brief overlook into it. It would do me, I'd be privileged if you would subscribe to my channel, like, and stick around for more videos to come. Thank you.